I've mentioned before that for you to do a good exploratory data analysis, you need to look at the data, see the data, and understand the data. Statistical analysis is very important for EDA and descriptive analysis, but it's not the only thing that you need to do. In fact, depending solely on statistical analysis can lead to wrong analysis, wrong data cleaning, wrong data modeling, just all wrong all around. And so far we've seen how visualizations can help us understand the data and even cleaning the data and figuring out what is the correct value to use or to substitute when replacing missing data or outliers. Let's take a look at this data set here. I'm going to actually open it in Visual Studio Code. It looks like it's a bunch of data sets with different names, all of which have different X and Y values. So I'm gonna go back to my notebook here and I'm gonna import them all as separate data frames. Right now it's all in a single data frame, so if I run datasaurus.sample and let's get a random 20 record, they're all sharing the same data frame essentially, just a data set, column, an X and a Y. So to do the splitting, I'm just calling a bunch of data frames, setting their values to equal the data source after filtering them based on the different conditions here. So the first one, I just want to see the dyno data set, the away, the H lines, V lines, so on and so forth. If we try to get the descriptive statistics about some of those data frames here, if I do dyno.describe, here's what I get. Let me try to do the same with a different one. Let's say the triad star, and let's get describe, and let's get the bullseye data frame and describe them. So if you look at the stats here, it looks like they're all sharing almost the same mean, almost the same standard deviation for both the X and the Y properties, almost the same median, and maybe the difference is really between them is in the minimum and the maximum, so maybe that's why some of the values are slightly different. So it looks like it was a huge data set that was split into different batches. Each one of those batches were giving a different name. And so for any one of those data sets, if I was working with them and I had a missing field that I need to substitute with some value, we've already talked about that. I'm just going to use the median or the mean of this value. But going with that assumption by just looking at the statistics is actually going to cause a lot of problems. Let's try to visualize these data sets here real quick. We'll do the matplotlib inline. Let's import matplotlib and import matplotlib.pyplot. SPLT. And because I want to put all the diagrams on a single figure, I'm going to use the subplot function here. So I'm going to do plot subplot is going to be a 5 by 3. The figure size is going to be 15 by 15. And for figure cleanness, and just to keep the figure a little bit clean and not have a bunch of axes, I'm going to have them all share the x-axis. So the subplot returns a figure and basically all the axes that we have. And I'm going to be deconstructing those axes into different ones, each of which will be used by a different chart essentially. So here's my x1, x2, x3, and let's do the second row. Alright, so for the first chart, I'm going to do a scatter plot for the away data frame. Here is my X and here is my Y, and we're gonna set the title for that one to be the away data frame. Alright, so we'll do the same for every single chart that we have. I missed an S up here. Alright, here we go. So let's run this one more time. And here we go. So even though they all share the same statistical values as far as the mean, the median, and all of that kind of stuff, they are very, very different. And so if I'm thinking about replacing a missing value with something, so that's another reason for why visualizations are really important before you just go ahead blindly and replace missing values with just the statistical values that you have.